Okay, let's talk about the domain and range of a square root function and the domain and range of an absolute value function. Now I want to do both of these at the same time in the same video because they have some features that are similar to one another, okay? But I will say that absolute value functions are very similar to whatever, if you take the absolute value of a rational function, you have to be concerned about the domain of a rational function. If you take the absolute value of a linear function, or a linear expression, I should say, then you're concerned about the domain of the linear expression, okay? And so let's start with absolute value, and then we'll go to square root, okay? So let me just give you straight up, the domain of an absolute value function is basically, I'm going to say basically the same as the domain of whatever is inside the absolute value symbols, the bars, okay? All right, so whatever's inside the bars, the domain of that absolute value function is going to be the domain of that. So for example, if I said f of x was equal to the absolute value of 5 over x minus 3, okay? Well, we know that the denominator cannot equal 0, and if we set x minus 3 not equal to 0, then the domain would not include 3, okay? And so the domain of this absolute value function would be negative infinity up to 3, leave 3 out, and then go up to infinity, okay? If it's, well, let's just stop there. But let's say that it's the absolute value of 5x minus 9. Well, this is a linear function inside, and we know that the absolute value of a linear function is negative infinity to positive infinity. And therefore, the domain of this absolute value function would also be negative infinity to positive infinity. If it was the absolute value of the cube root of x plus 1, then we know that the domain of a cube root function is negative infinity to positive infinity, and therefore the domain of this absolute value function would be negative infinity to positive infinity, okay? So basically, the domain of an absolute value function is going to be the same as the domain of whatever is inside the absolute value symbols, okay? But let's talk about the range of an absolute value function. We know that absolute values, and this is rule number 3. Remember math rule number 3 that we said in the introduction video? Is that absolute values never result in negative numbers. I think I said always result in positive numbers, but there's also 0, okay? So the absolute value of, let's say, x, whatever x is, the absolute value of x has to be greater than or equal to 0. And because it has to be greater than or equal to 0, it can't be a negative number. That means that the range, the answers, the set of answers for an absolute value function cannot include negative values. And so let's say that we had an absolute value of something that was called ax plus b. We're just going to call it the absolute value of ax plus b, okay? You know what? Actually, let's not call it that. Let's call it the absolute value of a function g of x. So the absolute value of the function g of x. So g of x is linear, or g of x is a rational function, but now f of x is the absolute value of that other function that's inside the absolute value of bars. This absolute value of g of x has to be greater than or equal to 0. And because it has to be greater than or equal to 0, that means that it's going to be 0 to infinity. Okay? So we're going to say the range for the absolute value of any function, okay? For the absolute value of it, and it has to be positive up here. If it's negative here, you have to multiply by -1 and move it to the other side, okay? So for the absolute value of any function g of x, or any answer for that matter, the range of an absolute value is 0 to infinity. Just 0 to infinity. That's it, okay? Because it's not going to include any negative numbers, but it can include 0, all right? All right, so that is the domain and range of an absolute value function, okay? Okay, so for square root, domain and range, I want to remember the rule that you cannot take the square root of a negative number, okay? And so, let's say that we have the square root of, I don't know, something like 4 minus 5x. 4 minus 5x. So let's say that this is a function. F of x is equal to the square root of 4 minus 5x. Okay? Well, here is what we need. Because we cannot take the square root of a negative number, we need whatever is under the radical, we have to set that greater than or equal to 0. So to be not negative, 4 minus 5x has to be either equal to 0, it either has to be equal to 0, or it has to be larger than 0. And so we're going to take whatever is under the radical and we're going to set it greater than or equal to 0. So to identify the domain of a square root function, what you're going to do is set what is under the radical symbol greater than or equal to 0 and solve. And solve for x. And solve it for x. Okay? So here we're going to solve for x. We are going to subtract 4 from both sides. We get negative 5x is greater than or equal to negative 4. And now we're going to divide by negative 5. Divide by negative 5. Now remember, when you divide by a negative number with an inequality, you have to reverse the symbol. So our greater than or equal to symbol is going to become less than or equal to because we're dividing by a negative. We're going to cancel here. We have x. And then we have negative 4 over negative 5. But remember, a negative divided by a negative is a positive. So this is actually 4 over 5. 4 over 5. And so we know that x can take on any value that is less than or equal to 4/5. And so when we solve for x, the domain of the square root is the solution to the inequality. Okay? And so the domain of this function right here is going to be all the values of x less than or equal to 4/5. And we know that we can write that as an interval. So d is going to be every number from negative infinity up to 4/5. And we're going to include 4/5. So we're going to put a bracket. So this is the domain of this square root function, okay? Let's do another example. All right, so here's another example. Let's identify the domain of this, and then we're going to identify the range. So we're going to take our 2x minus 11. We're going to set it greater than or equal to 0 because it can't be negative. We're going to add 11 to both sides. We're going to cancel, and we're going to get 2x is greater than or equal to 11. We're going to divide by 2 on both sides, and we get x is greater than or equal to 11 over 2. Greater than or equal to 11 over 2 means up to infinity. Okay? So our domain is going to be starting at 11 over 2 and going up to infinity. That's the domain of this square root function. Okay? All right, now let's talk about how do we get the range of a square root function. Well, to get the range of a square root function, here's what you have to understand. There's a very important rule. Now this goes against some of the things that we learned in the past, and it's complicated, and if you're curious, then send me an email and I'll explain it to you. There is a really good explanation, but it's just not, this is not the place for that explanation, okay? But I can tell you this, that in the world of math, we have, when we take the square root of a number, we have a concept called the principal square root, okay? And so we know that the square root of 9 technically can be 3 or negative 3. Because we know that 3 times 3 equals 9, and we know that negative 3 times negative 3 is equal to 9. So therefore, technically, because there are two numbers that multiplied by themselves will give us 9, the square root of 9 must be either one of those numbers. But when we say principal square root, we only mean the positive one. If we included 3 or negative 3, then we couldn't have a function. Okay? If we said f of x was equal to the square root of 9, okay, then this, whatever the input is, the answer is square root of 9. So if I put a 1 in here, I get the square root of 9. So don't worry about that right now. But because this can be 3 or negative 3, this function would have 2 outputs for every input. 2 outputs for every input. And then it wouldn't be a function. And therefore, if we're going to identify it as a function, there has to be only one answer. So we use, like I said, what's called the principal square root, which is the positive answer to this square root. Okay? And so what that means is that any square root function, the answer has to be positive, just like an absolute value function. And therefore, and this is one of the reasons why we're including square root in the same video with absolute value, the range, so we're going to say if f of x is equal to the square root of g of x, okay, then the range is the square root of g of x has to be greater than or equal to 0. And that means the range is going to be bracket 0 to infinity, just like absolute value, okay? And so that's how to identify the domain and the range of a square root function.